Hello and welcome to another edition of Raman Academy. What we're going to address today is the luminescence generated by glass when using 785 nanometer laser excitation. What you're looking at right now is a reflected light image of a microscope slide. I'll just turn the video on. Alright, turn to position 2. And you can see I'm moving the glass slide and I've got a little bit of dirt on the surface, which can allow us to see that we're in fact in focus. Alright, now we stop the video, change to the spectral position, and now we get initiate a real-time display. Alright, and now what do we see? We see, with no sample on the surface and just a glass microscope slide, we see essentially this very strong luminescence, and we are using a 100x objective right now. And so you could see that over essentially the entire fingerprint region, we're going to have this strong emission background as a result of the glass. Now, what I'm going to do is I've got the 100x objective, and I'm just going to rotate the turret so the spectrum vanishes for a moment, and now I put the 10x objective in place, and now look at how much more intense, we're up to 26,000, that luminescence is. Now, why is that? I'm just going to stop this for a moment. That's basically because in using the 10x objective, we have a much larger focal volume. So for the lower magnification, you'll be illuminating more oscillators, more material, more glass from the microscope slide. And so the lower the magnification, the greater your background is going to be. That is, if you're using glass microscope slide and 785 nanometer excitation. So how do we address that? That's what we'll talk about in our next segment. Alright, so now I have replaced the glass microscope slide with a piece of fused quartz, which come in small 1-inch squares or circular pieces, or even the conventional dimensions of a microscope slide, and they come from GM Associates. They're an excellent company, and they provide these fused quartz substrates as, I think, a very good substitute for microscope slides, and I'll show you why I believe that to be the case in just a moment. Alright, so we're looking at a reflected light real-time display. I'm moving the stage, and you see there's a little scratch on the surface, a little dirt on the surface of the fused quartz, so we are in focus. I'll stop the reflected light imaging and now move the selector to number 1 for real-time display, and we again have 785 nanometer excitation, and with that you see that the luminescence that we saw with the glass microscope slide is entirely gone, and all we see now is the Raman scattering. This is all Raman scattering from the fused quartz. Alright, and it's far, far less intense than the luminescence. Alright, now of course, if you have a sample that to some degree absorbs or refracts the light in some way so that it's not focused underneath in the glass, then this Raman scattering will be even more diminished. Now, as before, I'm going to rotate the turret and move the 100x objective out of place and put the 10x objective in place, and you can see that again we're seeing the Raman scattering from silicon dioxide. This is quartz, and again with the 10x, that Raman scattering is more intense, and that is because what we have is, with the lower magnification, smaller numerical aperture, we have a larger focal volume, and so even though the power density is less, that is compensated for by far more oscillators, if you will, SIO oscillators in the field of view. All right, let me just stop this for a moment, and then in our last section here, I'll show you the other alternative, which is to use an aluminum substrate. And now for our final segment, we're going to take a look at what a polished aluminum substrate, what kind of a background that can generate. So, and I think you'll see that that works out the best. Now, if you happen to need a transparent substrate, that's where the fused quartz comes into play. But if you can get away with an opaque substrate, then having something like this polished aluminum substrate, and I'm moving it around and you see a little bit of dirt on the surface to help us focus. A polished aluminum substrate works very well, and you won't get any kind of a real background. Now, I'll change the selector back to 1, put this on real-time display, and you see basically there's essentially some kind of a background, some very, very weak inelastic scattering, but essentially nothing really to speak of as far as there's no real Raman scattering because the substrate is aluminum, and there is no interfering luminescence in this case. Now, one other advantage is that if you have a transparent sample and you place it on this aluminum substrate, then you will also be able to take advantage of the fact that there will be a reflection, and the beam will then pass twice through the sample, and that too can help with increasing your Raman scattering. So the bottom line here is to remember that when using 785 nanometer excitation, the substrate that you use is particularly important, more so than is the case for the laser excitation wavelengths in the visible. Thanks for watching.